more than a decade after it was demoted. Pluto could soon be considered a planet again, along with more than 100 other objects in our solar system. Scientists have proposed a new way to define planets based on the physics of the world itself, citing technical flaws in the definition adopted by the International Astronomical Union in 2006 as a reason for the possible overhaul. If accepted, the geophysical definition would essentially classify all-round objects in space that are smaller than stars as planets, including Pluto, other dwarf planets, and even moons. Scientists from NASA's New Horizons mission will make their proposal at the Lunar Planetary Science Conference in March. The team argues that the IAU definition is flawed in several ways, including that it only recognizes as planets those which orbit our sun. This leaves out objects orbiting other stars or those orbiting freely through the galaxy. Along with this, they say there are parameters which even the planets in our solar system cannot satisfy. The new definition, they argue, would meet the needs of both scientific classification and people's intuition. By the proposed geophysical definition, a planet is a substellar mass body that has never undergone nuclear fusion and that has sufficient self-gravitation to assume a spheroidal shape adequately described by a triaxial ellipsoid regardless of its orbital parameters. Or, simply put, round objects in space that are smaller than stars. This definition holds the physics of the planet itself to more importance than the physics of its interactions with other objects, the researchers explain. Adopting this definition would see roughly 110 objects in the solar system classified as full-fledged planets, including dwarf planets and moon planets such as Ceres, Pluto, Charon, and our own moon. According to the proposal, the new definition would be better for scientists, educators, and students alike, as it is more intuitive and emphasizes the intrinsic physical properties of a planetary body, and it speaks to a practice that is already in use. In keeping with emphasizing intrinsic properties, our geophysical definition is directly based on the physics of the world itself rather than the physics of its interactions with external objects, the authors explain. Our definition captures the common usage already present in the planetary science community. In peer-reviewed planetary science publications and talks, the word planet often substitutes for the given name of the world, even if the world is a moon or a dwarf planet.